Hello friends, in this video we will go to see what is half power frequencies in network theory. Half power frequency is nothing but cutoff frequencies, that is the range of frequencies where the frequencies are start to rise and where the frequencies are fall. This is nothing but the half power frequencies. First, let's see the definition of half power frequency is the frequencies at which power becomes half of the maximum value are known as half power frequencies. Okay, let's consider this graph and consider this signal. Here P naught is the total power of the signal at maximum point, and P naught by 2 is the half power. What is the frequency at half power? That is nothing but half power frequency. Consider this P naught by 2 is the half power and this dotted line, and where this dotted line touch at the first, that is nothing but first half power frequency, and this point is nothing but second half power frequency, which means the power at which half of the maximum power, and that power at that frequency is nothing but half power frequency. Half power frequency nothing but at which frequency the power becomes half, that is nothing but the half power frequencies. Okay, here observe F1 and F2. These two are cutoff frequencies. F1 and F2 are half power frequencies. In other words, we can call it as a cutoff frequencies, and F0 is a resonant frequency. Okay, F0 is the in between the F1 and F2. This is the resonant frequency. Resonant frequency always takes at the maximum power. Okay, resonant frequency F0 is always takes when we got the maximum power, and cutoff frequency always takes half of the maximum power, that is P0 by 2. Now let's see how to find half power frequencies. Okay, here let's see how to find half power frequencies, determination of half power frequencies. We know we have two half power frequencies, one is F1, another one is F2. Okay, at a half power frequency is the net reactance of the circuit is equal to resistance of the circuit. At half power frequency, the reactance equal to resistance. They said that reactance is denoted by X, resistance is denoted by R. At half power frequencies, reactance equal to resistance. Okay, first let find the F1. We have two half power frequencies, F1 and F2. We can call this half power frequencies are the cutoff frequencies also. This F1 is the lower cutoff frequency and F2 is the upper cutoff frequency. Okay, now first find the F1. For finding the F1, let's assume, this is the assumption, XC1 is greater than XL1. XC1 is nothing but capacitive reactance is greater than inductive reactance. Here they already said at half hour frequencies reactance equal to the resistance. We know total resistance, total reactance equal to XC1 minus XL1. Okay, XC1 minus XL1. The difference between the capacitive reactance and inductive reactance is nothing but total reactance. That's why we, in place of X, we simply substitute XC1 minus XL1 equal to R. We know XC1 is equal to 1 by omega 1C. Okay, XC1 equal to 1 by omega 1C and XL1 equal to omega 1L equal to R. Simply move this term into this side, that is omega 1 CR into omega 1 square L1 into C. Okay, next let's see here omega 1 square LC, move this to this side, then we get omega 1 square LC plus omega 1 CR and minus 1 equal to 0. Consider this is the equation number 1. Now we need to find the omega 1 value from this equation. Okay, we need to find omega 1 value from the from the equation number 1. We will get omega 1 equal to minus CR plus or minus root of C square R square plus 4 LC by 2 LC. Okay, simply move all term to this side. we can get omega 1. Okay, here simplify this equation also. That's why we can get minus r by 2l plus or minus root of c square r square plus 4lc by 2lc, and omega 1 equal to minus r by 2l plus or minus root of r square c square by 4l square c square plus 4lc by 4l square c square. This is the resultant lower half power frequencies or lower cutoff frequency omega 1. Okay, that is omega lower cutoff frequency omega 1 equal to minus r by 2l plus or minus root of r square plus 4l square plus 1 by lc radians per second. It is in terms of radians per second. uh, when we represent this lower cutoff frequency in terms of frequency or hertz, then we can simply, this is the frequency in terms of hertz, that is f1 equal to omega 1 by 2 pi, that is 1 by 2 pi into what is omega 1. Omega 1 is nothing but minus r by what is this, let's see here, minus 1 r by 2l. Okay, that is this minus r by 2l plus or minus root of r square r 4l square. We can simply represent r by 2l whole square plus 1 by lc hs. Okay, this is the lower cutoff frequency or lower half power frequency. Now we need to find the upper half power frequency. Okay, upper half power frequency nothing but f2. Here assume xl2 is greater than xc2. xl2 is nothing but, what is xl2? xl2 is the inductive reactance, xc2 is the capacitive reactance. When xl2 is equal to the xc2, then the reactance equal to resistance, then the total reactance is nothing but difference between the xl2 and xc2, that is xl2 minus xc2 is equal to r. We know inductive reactance is equal to omega l. Here omega is nothing but omega 2 into l minus capacitive reactance is nothing but 1 by omega c. Here omega is nothing but omega 2, 1 by omega 2 c equal to r. Now simply move this omega 2c into this side and we will get omega 2 square lc minus 1 equal to r omega 2c. Okay, now move this r omega 2c into this side, then we will get omega 2 square lc minus r omega 2 cr minus 1 equal to 0. Consider this is the equation number 2. Now we need to find the omega 2 value. Simply move all the terms except omega 2 to this side, then we will get this equation, that is omega 2 equal to rc plus or minus root of c square r square plus 4lc by 2lc. Okay, and simplify this equation, we will get r by 2l because this c and c get cancelled plus or minus root of l by 2l r by 2l whole square plus 1 by rc radians per seconds. This is the higher cutoff frequency in terms of radians per seconds. Suppose we need to represent this higher cutoff frequency in terms of hertz, then simply divide this equation into 2 pi, that is f2 is equal to omega 2 by 2 pi. Omega 2 is nothing but this thing, 1 by 2 pi into r by 2l plus or minus root of r by 2l whole square plus 1 by c hertz. These are the upper and lower cutoff frequencies. Okay, thank you for watching this video.